Good evening, everybody, and welcome to the Triangle Area SQL Server User Group's Advanced DBA meeting for this month of October 2022. Tonight, Edward Pollack, he's going to talk to us all about finding gaps in islands and using complex data sets. I'm pretty sure I saw a version of this talk from a few years ago or something similar to it from Ed, so it's going to be fantastic. But before I hand it over, I do have one quick thing, and that is a link to the Tripass semi-annual survey, by which I mean once every 2 years, not twice every single year. It's always got to clarify that. But I'm only going to ask you this for the next 3 weeks, so if you haven't already and you're a Tripass member, please do fill out the survey on the screen there. And now, if you would, please take it away.
Cool. Thank you very much for having me here today. I hope this will be fun. This is kind of an interesting topic. It's very different from a lot of other presentations I give because this is not about, learning the T-SQL and how to do something exactly. It's really about what you can accomplish using a tool if you want to. So this really is a dive into crazy, gnarly T-SQL. It's a dive into analytics and into a problem that is often oversimplified. The gaps island problem is classic. It's everywhere. You can go on the internet and search for it. And unless you happen to find an article I've written, odds are very, very good it's going to be like, hey, 1, 2, 3, 4, 6, find the gap. And you're going to kind of chuckle and say, okay, I can do that. And you'll write something to do it. But it's not a very interesting problem to solve. The goal here is to work our way up to data that's interesting. And so I'm going to have 2 data sets today. The first will be AdventureWorks just for the demos in the beginning. And then I have my own database of baseball stats that has all the baseball games for the past all years. That one we use for the more advanced stuff because the data is big, nasty, messy, never pass QA kind of deal. Makes it perfect for analytics in real life. So I'm going to dive right on in. This is who I am. I've done a lot of stuff in the data world. I'm a data platform MVP as of like a week ago. Yay! I've published books. I speak a lot. I go to a lot of events. I kind of enjoy this, which makes me kind of a masochist. But I do enjoy this. I've organized many other events, including SQL Saturdays Albany. I've worked in New Jersey, New York City, and other ones. So this is fun for me. Feel free whenever this is over, or even before, to hit me up on Twitter, email, whatever. I'll have my info at the end as well. If you have questions or anything later on, you want to chat, feel free. All right, here's what we're going to do. I have some review in the beginning about just basically how can you group data together and make some meaning out of it. And the very basic review of what is the gaps and islands problem and why do we care about it. And then I'm going to dive into basically just section after section of progressively more complex. What can we do with T-SQL to solve a problem that is hard to solve otherwise, or what almost perceived as impossible to solve otherwise? And there is no impossible here, but these are things that without some forethought are very difficult to solve. And this takes an hour. I'd be surprised. I tend to go very quickly, but again, Kevin has been given the heads up, go ahead to interrupt me with anything he wants, so you can do that. The simplest way really to deal with the gaps and islands, well, not even gaps and islands, simplest way to get meaning out of data is through the group by statement. We do this all the time. This is natural to us as developers, as DBAs, as architects, as anybody. You take a big pile of analytic data, you group by a column, and you get your counts and sums and mins and maxes. This is very basic. This is nothing complicated. Most of us have done it before. It's pretty natural. It's pretty normal. Cool. But it's worth talking about, though, because you can get a lot of meaning out of this data, but how do you really use it for finding trends over time? And there's good things about it. It's very predictable. You can put it into segments. You know exactly how many segments there are of data. You can pick up rules and use those rules, and those rules guide your data. And you can kind of do whatever you want. The result set will be predictable. It'll be what you expect, which if you know what you want is good. If you're not quite sure what you want, it may be misleading. The little example over on the right here shows dates, and you can group them and say, you know what, I'm going to group them into months. I'm going to group them into hours, days, years, whatever. You can group and get date parts and then sum up whatever you want within those dates. It's simple, but there is a downside. The downside is the same thing as the upside, is that's very predictable. If you have data that's very inconsistent or has boundaries that are unusual, like you want to segment your data by day, but interesting things happen at certain times of the day, you may lose a lot of that granularity. You may not even know those things happen. And since you're picking the boundaries, you may pick good ones, or you may pick bad ones and not know it. So it's very basic. We know how it works, but it doesn't always solve problems the way you want to solve them, especially if the problem is identifying chunks of data that occur in sequence or gaps in that. I mean, it sounds like gaps and islands because it is, but it's not really great for that. You can use it as a way to kind of understand your data and keep grouping by different amounts. think we've all at some point done that. Group by year, okay, group by quarter, group by month, group by day, hour, minute, and eventually find stuff. But that's kind of cumbersome, and there's still no guarantee you're not going to miss stuff, especially when the data is huge. Your ability to zoom in and find the one special thing out of a million or a billion rows is very hard. And this is a very easy thing to demo. I'll bring up Management Studio. There it is. This is a simple demo. Imagine you have an on-call error log. So whenever something, you go on call every night. When things break, you deal with them, you log it, and we keep track of all that stuff. And then somebody goes back later and looks at it and says, hey, what happened on call? Were there patterns? Were there things that broke in sequence? Were things related or not? So I'm going to create a really simple table here to store this data. I'm going to put an index on it just for the sake of doing the right thing. You put an index on date time because when I analyze this data. Now throw a whole bunch of data in there. Probably looks familiar. Maybe giving you nightmares of the times you may have been on call in your life, which is great. We should all have nightmares about that, right? And I can look at this data. And I can see here that I have a pile of data. I can see that different points in time over the course of a few months, things happen to print servers or SQL servers or whatever. And then I have some detail as to what happened. Let's say I want to understand errors over time or patterns in that data. One way to do that would be to say, all right, group by the date and then give me a count of errors. That's all. Pretty simple, right? So there I go. I found that on 7 different dates I had errors occur. Some dates had a lot, 9, 4, 3, 4. Some had just 1, and all the rest of the missing dates are zeros. And of course, I could take a dates table, numbers table, sequence table, left join, and get all the missing dates and put zeros there too. I didn't do that here, but you could if you want. Similarly, I can then say, all right, well, grouping by date shows me some interesting things here. What if I group by hour? And yes, you could use new 2022 features like the date trunk or the other new functions to like get better date parts without doing this ugly thing that I'm doing here. That's new, though. I'm not going to do a new thing yet. I can see here that if I go down to the hour, that there's certain hours that had some interesting things happen together that I might be interested in. Like, hey, what happened here that 3 different things broke at the same time? Was it the same thing 3 times, or was it 3 related things? Maybe the network went down, and when the network went down, the print server went down, and the SQL server went down, and when the SQL server went down, the app went down, and when the app went down, people made phone calls and were mad. Those things happen, they're related. So this is kind of what we're looking at here for the kind of inorganic grouping. And the key to it is that we assign ourselves whatever we want. If we had sales data, for example, like this right here, I could do a very similar thing and say, give me the total sales per day for a given year. And here we go, a big mountain of data per day. I can then add some intelligence to it and say things like, hey, I want to understand when the total sales were low out of all those. So I can add a having clause to it. I can get my number out of that. I can run my query. I get back a smaller set that shows me specific outliers when the sales were low. Well, what happened? Why were the sales low? The upside is I know when sales were low. The downside is I don't really know what led up to it. I don't know if it's a pattern or not. I don't know if there was a thing related to it. I just know that here's points in time where things were not quite what we wanted them to be. Could be a reason. It could be a holiday. Could be something special. Who knows? But there's some information. So that's the basic idea here of just structured groupings, is that you assign it, you provide the rules, the data gives you back what you want, and hopefully you guessed correctly. Gaps Islands analysis takes a different approach where you say, all right, my data is going to have chunks of data that I care about, and it's going to have missing areas we call gaps. So you have gaps or missing areas, you have islands, which are chunks of data. And we can use this kind of analysis to understand how data groups together. This is really good when you want to understand when things are supposed to be there or missing. If you want to understand streaks or analytics that based on borders or edge cases of things. It's really great for that. The data creates its own rules, though. You'll apply your own rules, but the amount of data you get back and the amount of chunks of data will vary. In the example here for integers, you can see in this list here, I have some missing numbers. I'm missing 6, I'm missing 9, I'm missing 11, and so forth. And when I take this integer list and I group it into islands by integer, I can see that now I've grouped it into chunks. I have 1, 2, 3, 4 islands of data, in between of which there are 1, 2, 3 gaps. Those are what gaps and islands are. Ultimately, to get that, you've got to join data together. So you have previous and next. That's kind of the whole basis of understanding gaps and islands, is that for every row of data you have, there's something that came before it and something that came after it. And if the thing after it is missing, you have an island. The thing after it is there, it's a gap. The thing after it is there, and that's part of an island. And then obviously there's the beginning of a data set. We have nothing before it. You have the end of the data set. There's nothing after it. So I guess the infinite gap would be the beginning and end, before and after that. If you have dates, you can do gaps and islands on dates as well. I can say, 1 through 1.3 is an island, 1.7 through 1.8 is an island, and so forth. Doesn't really matter. These are simple use cases where the wow, really, right now? Come on. These are simple cases where I can very easily understand how I'm incrementing here. For the integers, I'm incrementing by 1, and for the dates, I'm incrementing by a day. That's pretty straightforward, easy to understand, pretty simple analytics. How does this look in real life? And again, feel free to stop me with questions. I'd be happy to answer questions, or I'll just charge forward at full speed through what will get to be crazier and crazier TSQL. So let's insert some more stuff into our table here, on-call error log, and then we'll delete some rows and take some things out. So insert, delete, insert, delete, insert, delete. All right. Now we can look at our error log here and see we have a wide variety of data here on different dates, different times. So let's say I want to understand missing, just something very simple here, missing PK values. This is the most simplest example of gap silence analysis. I want to look at the integer value in this first column and understand when is it there and when is it not there. Because the PK, it's auto numbering identity, and I deleted some rows, we know some are missing. So the first thing you have to do is identify the start. You have to identify gaps. So you need to know, is there a value after your current value? So if I have the value 1, is there a 2? If I have 5, is there a 6? I can run a query like this where I simply say, select my ID plus 1 from, and I'm checking to see where not exists something right after it. And I'm also verifying that I'm not looking at the same ID. You can do it as a join as well if you want. Any kind of correlated subquery, you can probably put it together. There's a lot of ways to do this, and there is no right or wrong way to do it. Ultimately, it's going to be based on how you like coding and how fast you want it to be. If I run this query, what I'm basically saying is check my log for any ID that has a missing ID next, and I get back 3. And I can verify that back up here because I did some deletes. And those deletes remove the rows. So I know I have 3 rows missing that I got rid of earlier. Those are my gaps. I can, if I want, add in the ending ID. So I have my starting ID for a gap. The ending ID will be the next ID in the sequence after the current one. So I know when my gap starts, what's the next island after that, and that'll be the beginning of the island. The ID before that will be the end of the gap. This does sound a little complicated. I will share all of this at the end. I will post all the extra database that I created, as well as all the SQL in the presentation, to the meetup page, so you're not frantically screenshotting or writing code down because there's simply too much of this, and it's not meant to be simple. It's really meant to be a proof of concept of what can you do if you put your mind to it and really want to do it. So same query as before, and to kind of walk through it, I'm not going to walk through every single query in full detail. I'm basically saying, select from my table where there is not a row directly after it. That is, the ID plus 1 is not equal to the ID. I'm checking to make sure that it's less than the max ID in the table, because I don't want to accidentally go off the end of the table. I'm in the last row of the table. There is no gap after it. I'm just done with my data. And I'm going to order by the ID. This shows me my gaps, 24 to 25, 28 to 31, 36 to 36. So I have 3 total gaps. This one's length 2. That one is length 4. And this one is length 1. Cool. So now that I have the starting ID of a gap and the ending ID of a gap, I can self-join this whole mess together. And you'll notice this TSQL gets kind of big. I do it this way intentionally. You may be thinking, Ed, I could think of a way to optimize, make it a little faster. But I'm intentionally going to use the syntax that I used tonight repeatedly, because it's a little easier to cut, paste, and put together in blocks, which for a developer is a little easier. For an analyst, a little easier. It may not necessarily perform amazingly well, but I do have a slide on performance later on. If you're the performance nut, like I can be sometimes, I'm not neglecting you, I promise. All right. So we'll self-join it and really just say I'm going to join my gaps here. I'm going to select from it. inner join starting points to ending points, and the only real join is just on my current row is equal to the row, the next row is equal to the current row plus 1. And then I just have my validation here to make sure that I know there's a gap in there. So I'm checking to see is the ID gap greater than 1. When I do that, I get back the same data as before. I can see my gap of 2, my gap of 4, my gap of 1. So this self-join is a nice way to do it. You can also write it with a nested subquery if you want, and throw the select min in here. Give me the min ID from my data set where it's greater than the current one, but is a gap. And then I can join it together and get my results. Again, same results. You can probably think of 5 or 10 other ways to do it, and they're all valid. We're not talking performance yet, so if you can get the right data, bravo. Identifying islands is very similar. For an island, I'm going to get a little tricky here because I'm working with a PK. I can do this right now. I'm going to say, here's my current ID. I'm then going to get the row number over for my ID to find the row number. So I know at the sequence of integers that I have my current ID, and then I have the row number over my data set. And if they don't match, I know a gap has occurred, and I can compare those. If I have 10 rows in my data set, but I'm numbering up to 13, I know there's 3 missing. So I can run this in my same data set, and I can see that I have an island going from 1 to 23, 26 to 7, 32 to 35, 37 to 37, the end of my data set. You can do a very similar thing with dense rank if you want. Again, these are all different ways of writing the same code. You're more than welcome to go on the internet and look up performance comparisons or different code comparisons, depending on what version of SQL you're on, SQL Server. Not every function in this presentation will be available, but everything in here has been available for a little while. I think until at least possibly as 2012, at least it'll work under. So there's nothing terribly new in here. And that was intentional. It's really more about analytics, not about showcasing shiny new things. I can use dense rank, get the same results, no problem. This is the syntax I'm going to prefer for the remainder of the evening. It's longer, but it's very explicit. I'm going to say, give me a set of all the starts of my islands. That is, I want all of the IDs for which there is not an ID after it. So I'm checking, sorry, before it. So I'm taking an ID and saying, is there something right before it? If no, that's the beginning of an island. And then island end is the opposite. Island end says, hey, give me all of the IDs for which there is not one after it. That will be the end of an island. And at the end of the day, the size of each of these data sets is the same. I have n number of island starts. I will have n number of island ends. Therefore, I can join them together to get my islands. And yes, this looks totally crazy, but I can view my set and see here's my island starts. Here's my island ends. There's 4 of each. There should always be the same number of each. If there isn't, that means that I made a mistake in my code, or I have a QA problem with my data, a data quality issue. We'll talk about that later as well, because data quality is important. I run this, and I get my same results as earlier. I will stick with the longer syntax because it's nice, it's convenient, and it's very easy to cut, paste, and code. Like I can just take my code and paste other stuff into it, and it'll work, which is kind of fun. All right. So far, this has been all integers, pretty much. Very simple, very straightforward. This is the classic gaps and islands problem that I said was boring and would put you to sleep. The rest of this presentation is about using other kinds of data to analyze it. I'm going to call these data clusters. It's not really a data cluster. I'm talking about clustering in SQL Server or whatever. We're just talking about a chunk of data. But to call it a gap or an island is kind of weird because we're not grouping by anything of like, integer separate by 1 or date separate by a day. The idea here is you're going to take and create rules for what makes data be part of an island or a gap. You're going to apply those rules to your data, and that's going to result in the creation of gaps and islands within your data. But the difference in space between each data point will be different. It might be an hour, a minute, a second. It'll depend on what my rules are. So for example, I'll have times, very specific times, like this. And the result will be a cluster of data that may go from a very awkward time to a very awkward time. But these are real dates and times that things happen, which is why it's nice. I'm looking at my on-call error data from before, and I want to know when errors occurred. I don't care if it happened between midnight and 1. I want to know what's the time of the first error in that cluster of errors, and what's the time of the last one, and what happened in between. To me, that has a more organic feel to it, and then I can include stats and counts and sums and stuff like that to understand the meaning of that data. The key to this, though, is you need to invent rules to understand your data. So you've got to kind of understand your data, which is important, and how to create the rules and be accepting of the fact that you could fail, make mistakes, and try again. In many ways, it's kind of like training machine learning, but this is not machine learning. But there are some similarities in nature to it. So how does this look? Let's say I have my on-call error log, and I want to say rule number 1. All errors that occur within 30 minutes of another error are somehow related. I'm making this up. It may not be true. But I'm just saying for the case of this demonstration, every error that happens in 30 minutes of another error is related, and I want to know that. So here's what I do. I have my island start, and I am row numbering it and ordering by the error date time, and then by the ID as a tiebreaker. That's my row number. I'm going to check not exists. And the only difference between this and what I did before is I'm checking to say, I want to check to see, is there any, for the island start, is there an error within 30 minutes before this one? If yes, it's not the beginning of an island. If no, it's the beginning of an island because 30 minutes or more before it, nothing has happened. Then I'm just verifying the ID. The date time is less than the current one because I don't want to accidentally have some self-join if I have the same date twice. Then I just have the not exist here to verify dupe checking. Because again, things could happen at the same exact time, and if they do, I don't want to have some weird join condition where I cross-join myself and get extra rows back. The island end is exactly the same, but in reverse. I'm going to go ahead and check to say, all right, is there an error within 30 minutes after this row? If yes, it's part of an island, but if no, it's the end of an island. So now I have my island start, which has nothing right before it for 30 minutes, my island end, which has nothing after it for 30 minutes, and I can then just join them together. And there should be the same numbers unless I made a mistake in my data. And I'm just checking for dupes here to make sure I don't accidentally have dupes. And then all I do at the end is join them together. And for fun, I put a little subquery count in there to see how many were in that island. If I run this big scary pile of SQL, we can see that I have now a more organic listing of my errors here. And you can see the number of rows here is 18. That number of rows is not pre-prescribed. The number of rows is going to be based on my data. That's it. If I have my errors could all be in one cluster. I could have a single row here, or I could have 1,000. It will all depend on my data and when things happen. And I can see here more detail that's interesting. For example, from 5:54 on this date to 6, 5 errors occurred. This is a lot more meaning than knowing 5 errors happened from 5 to 6. And I know exactly when they started and when they ended, and I can analyze that further if I wish. I could say, hey, from 5:54 to 6 on this date, 4 things occurred. Well, that's suspicious. Exact same start and end times. That's curious. And then, of course, once I have this final result set here, it's only 18 rows. I can throw that into a temporary table and analyze it further. And now I have small data. I can do whatever I want with it. Getting the data at this point can be expensive, but once I've crunched it into these islands of data, these data clusters, I can do whatever I want with it very fast because 18 rows of data with 3 columns is not a big deal. Cool. I can make a different rule here. All errors that occur within 60 minutes of each other are related. So exact same query as before, but I now just have the number 60 here instead of 30. I didn't really change much of anything. But I decided, hey, this is more meaningful. Let's try this. So I run it. You'll notice I got less rows back this time because more things clustered together because I gave it a wider window to select from. That's the only difference, though, is 60 instead of 30. So I said if I have anything that's 60 minutes before, that's part of this island. Anything 60 minutes after is then. If I don't, I have a start and end for an island of data. And I can see here that if I go by an hour, I get a wider chunk here because these things are grouping together. You may say, hey, 5:54 to 7, that's more than an hour. What happened, Ed? But my rule didn't say I want to group by hour. My rule said if I have anything occur within an hour of the last one. So they could be strung along. I could have days and days of data strung together here. So if I made my numbers too big, I'd eventually have it all just be one giant clump of data. So what your rule is will be based on your business rules and how you understand your data. I can adjust the rule more and say, I want all errors that occur within 60 minutes of each other, but also for the same server. And the only thing I'm going to do here now to make it different is when I go here and do my checking, I'm just going to have an additional, in my where clause, check for the error source. So I'm going to say, did it happen within 60 minutes and on the same error source? I'll use that here for dupe checking. The end IDs are exactly the same. I'm just going to check source in addition to date time, source in addition to date time, And then at the end, I just join on my row counts, like my row numbers. And if I run this, I'll see that I have more rows coming back now because the number of times the server's end times match will be less frequent. So I'll get back more islands that have less things in each. But I can see here some interesting stuff, like from 6 to 7, this one application broke 3 times, or this print server went down 3 times in a 2-hour, 3-hour period. 2-hour? Yeah, whatever. You know what I mean. And so on and so forth. We don't have to know how to count here, right? Don't hold me to that. It's probably being recorded, and I can't count. Awesome. Whatever. So we can keep going and make up our rules and join however we wish and decide what's most meaningful for us here. For example, I can say errors within 15 minutes of each other are related, but only include the ones during business hours, Monday to Friday, 7 to 7. This may sound crazy, but it's not that hard. I can simply say, here's my 15-minute increment, and then I can add in the whole, this is where clause here. All I'm doing is adjust my where clause to get what I want. So the filters that you have really control what your rules are. I omit Saturday and Sunday, and I check for 7 a.m. to 7 p.m. That's my rules here. I made them up. I can do whatever I want, right? So the SQL is bigger and crazier, but the same idea is really the same. I just added in 2 lines of SQL to omit Saturday, Sunday, omit after hours. The final join is always the same, by the way. If you haven't noticed yet, this last chunk of SQL here, this 8 lines of SQL are exactly the same in every example so far. It hasn't changed one bit. All the adjustments have been made up here in the CTEs, which is why I like to use them, because you can adjust your CTEs and everything flows through. I do this and discover, wow, all my application outages, almost all of them, occurred after hours. Only 3 things happened during business hours that I care about. I don't care about after hours. So now I'm down to 3 things I care about. Life is good. This is one way to get that information and understand it. All right, cool. So far I've introduced the idea of gaps and islands and how to find gaps in data or islands in data based on the idea of proximity. So for every row in your data set, you order it and say that I'm going to look at the rows before and after it and make a determination if they're related or not. And if they're related, they're part of an island together. If they're not related, there's a gap somewhere in there. And you have your beginning and end of your data set that start and end everything. Data clusters show that I can do that with other kinds of data, like date times. You can technically do it with any kind of data you want, decimals, strings, as long as you can order your data and have a rule by which each row somehow can relate or not relate to the row before it or after it, then you can make data cluster. So you can use anything. You could use, var binary. You could use unique identifier. Get imaginative here. You could throw a JSON in. I don't know why you would do these things, by the way. I'm just saying you could. But you could do that if you really wanted to. Because of this now, we can take this methodology and apply it towards more interesting questions. You can look at data and ask questions that are hard to answer using traditional methods. Even traditional analytics might make it hard to answer. And we can use this method here to go ahead and order our data, create chunks in it, islands, clusters, whatever you want to call them, and then figure out metrics. Your where clauses will control your rules. Your join predicates will determine how you're going to group your data together. And then you can calculate whatever you want. And if you're looking at creative and make your computer scream a little bit, your server, you can use dynamic SQL or some other iterative method to take your process and iterate over any number of variables. I can say, hey, I don't know what number of minutes makes sense for my on-call data. So you know what? I'm going to create a variable, assign 1 to it, and then count up to 150 minutes and test all of them. Create all my data sets, look at all of them one time to see, you know what? How does my data look when I group it? Pick the best one or ones, and then use that going forward. So you can kind of create a model, test it, play with it, and run with it. And there are other tools to do that as well. You don't have to do TSQL for it, but this is kind of fun because it's a tool we have available and it shows the kind of crazy stuff you can do when you want to. So I'm going to spend a lot of time now, pretty much the rest of our time, on how to use this methodology to do crazy things. Worth asking quick, are there any questions so far? I know I've been diving in, getting more and more complex as we go. Are there any questions on anything, or are we good to keep diving in further?
I think we are good to dive. No questions so far.
All right, no melted brains yet. Great. I did not bring the debugger out. I do not plan to bring the debugger out during the session. I promise. I guess if you really want me to, I could, but it wouldn't be that interesting, I guess. Okay, well, let's answer tough questions. Let's take a fun data set. So I have a database that I created years ago that I've been updating every year that has every baseball game in it going back through all of history. I call this database Baseball Stats. It's not a terribly advanced database. I didn't create a really cool, perfect chunk of data here. I intentionally wanted raw, messy data, and this is a good place to pick it. Because in baseball, going back to the 1800s, when databases didn't really exist as we know them, data was not always perfect. There is weird stuff in here. And I intentionally did not filter out the weird stuff because I want the weird stuff. I want a realistic data set, and realistic data is not perfect. That's just life. There's two tables I'm interested in here I'm going to play with. I have many others, but we'll just kind of work with two. One is called game log. This is one row per game that is a high-level summary of stats from the game. And by stats, I mean all the stats. Every detail, like how many triple plays did the home team have, double plays, who is the umpire. I have lookup tables for a lot of this. So extremely detailed data set here with a massive amount of information that I can crunch. I'm not going to use most of it. I could, but I won't. But there you go. So one row per game. I also have an additional table that has one row per event. So every game is broken into events, like hits and outs and things. Each of those is an event, and I keep track of all of them. So you can see here, for example, in this game from 1922 that was randomly came up with a select star, that here's what happened in this one random game, a detail of one event. In this case, what happened? It was a leadoff, at bat for an inning, and there's a whole bunch of information here about what happened. Again, lots of lookups and things, but one row per event. How many rows of data are we looking at here? I have a total of 225,000 baseball games, and I have a total of 12 million game events that occurred within those. So it's not big data, but I wouldn't call it tiny data either. And it's definitely messy data, which I like. We can do an infinite number of things with this data. So here's what I want to do. I want to take a data set for a baseball team. I chose the Yankees here because I live in New York, but you can choose any team you want. And I'll choose a few other ones later to keep things fair before I get beaten up for picking the New York team. But I want to say, hey, let's take every game and assign the basic idea of I want to know all the games the Yankees won or lost. Or tied, because ties used to occur. When I forgot about ties and remembered, oh yeah, in the 1910s, before they had lighted stadiums, games were called in the count of darkness, and there were ties. Right, of course. That's in the data. Control the results of the game and get back for every game for the Yankees. All however many rows came back. Where's my row count? The heck? That's weird. I don't have my little thingy on the bottom. Is it still running or something? Well, either way, I have 18,500 rows, so I know how many there are here, and I can see for each one I put a W, an L, or there may be some T's in there as well. If I search around, there might be some T's. Are there any? I'm not going to look right now, but there probably are some. Now that I know if they won or lost, I also know all the games they played. So in theory, I could use gaps and islands analysis to understand how many wins or losses they had in a row and call those streaks. So here's my exact same query from earlier. It defines whether a game is a win, a loss. Again, if they're the home team and they beat the visiting team, that's a win. If they're the home team, if the home team beats them and they're the visiting team, they lose, and vice versa. And if the score is equal, they're a tie. That's the result. I then order it by game date and game number because you have more than one game in a day. That happens. And then I'm checking to see whenever they're the home team or the away team. And I'm only doing regular season games here. So a lot of little detail that I put in here. There we go. And then I say start our winning streak. A start of a winning streak would be a win where the last game before it happened to not be a win. That's the definition of a winning streak. I won a game. Woohoo! The end of the winning streak would be I have a game that's a win, and the next game after it is not a win. By definition, my streak ended. My next game is not a win. So now I know my first win of a streak and my last win in a streak. And in this case, streak and data cluster and data island are all the same things. Different terminology, but same exact thing. And here's my exact same select statement as earlier. I just have a different table name, but basically same exact thing. I get my start date, end date, number of count of games in between, and then I join them on the start num equals the end num, because I make the assumption that if I have 500 starts of streaks and 500 ends, they'll join together evenly unless I made a mistake. I didn't make a mistake here because I presented this before. I did make mistakes in the past in my presentations in this and got embarrassed. I will not embarrass myself today, hopefully. This is taking a little while to run. It's crunching a lot of data. And here we go. This is every winning streak in Yankees history. I can see, for example, a lot of ones. I can see a 3 here. I can scroll through randomly and just see what I find for fun. I'll see 5 here from these 2 dates in May in 1916. So there's a lot of data here going back a long ways. And I included all the additional star as well, which is probably why it was kind of slow. But it can also tell me what interesting facts there were about the first and last game of a streak. So I have all this information here. Oh, a 10-game winning streak. Wow, it goes from, May all the way to June. So some bigger ones as well. This gives me all that information. So I know, based on this data, that I have a total of 4,425 streaks, anywhere from 1 to, wow, there's 13 games right there. That's pretty cool. And in theory, a streak could start at the end of the season and continue with the next season. I have nothing here that stops that from happening. April is greater than November of the year before, so that is a thing. All right, so now I have all the winning streaks for the Yankees. I can simply take those results that I got and work with them, right? I have this big list now, and this is only 4,425 rows in my result set. This is not big data. I did the crunching already. The crunching is over. My poor machine here cried a bit. It's done. Now that I have those results, I can analyze them. So I can do exactly what I did before. Get all my baseball games, assign wins or losses, then get the start of the winning streaks, the end of the winning streaks, and then all I do at the end here is get a few more metrics here. I can get the numbers of dates, the starts, the ends, and get the winning streak length from this. All I'm really doing is adding an order by here. Order by the end of the streak minus the start of the streak to see how many rows are in each data set. That's the length of the streak. If I do this, the computer will cry for a moment or two. You can hear it actually powering a little higher right now. The local power supplier is getting strained. All right, so here we go. The longest winning streak in the history of the Yankees was 19 games. It began on June 29th with 47 in game 2 that day, strangely enough. And it ended on July 17th of 1947, also in game 2 of a doubleheader. Interesting. I get additional information, all kinds of additional information over here. And I can then work my way down and see 19, 18, 16, 15, and so on and so forth. And there we go. And just for a point of information, this data is complete through 2021. I will add the 2022 data in soon when the season's fully over. It's not over yet. So there you go. I can see all of my streaks from earlier ordered, and I can ask when the largest and shortest was and details and get that information out. Now, if I want better performance, which performance is important to me, I don't have to use the same syntax that I'm using here with subqueries. I could use lead and lag. The SQL is still a smidge ugly, but I can say, hey, take my game, take my lag, take my lead, and then I can compare them. So now I know my current row that I'm looking at in a window. I can then take the lead, take the lag, and then understand what happened before and after. And using the 2022 feature window, I could take my common window and bring it down to the bottom and save more TSQL space. I didn't do that here, only because I didn't want to highlight brand new features. It's not really the point of the presentation, but if you want to use window, you can shrink your TSQL and make it more compact. So otherwise, it's exactly the same. Island start, island end, and get my information at the end. The only difference is I made the beginning of it a little cleaner because I put lead and lag in and all the subqueries that were kind of ucky before. If I run this, off my machine goes, it gets a little toasty, smoke rises, and then I get my results back. In this case, it wasn't much faster, but it is cleaner TSQL, which I do appreciate. Same results as before. There's that 19-game winning streak. There it is. I even have the island number there for reasons I'm not sure. But again, if you're debugging code that isn't working well, you're trying to understand why is my gaps islands analysis not functioning the way you expect it would, having information like the island number or the start and end location for an island is useful. You can find out where things don't match up correctly and then find that problem and fix it. And it's usually going to be a QA issue. Like you're not taking into account duplicate data or null or things like that that might appear in your data set that you may want to deal with, and you can then clean up your data. And it's this first select here, this first with, that kind of presents your data set. And then I just do the island start, island end, join done. Cool. All right. Let's say we want to remove some columns and make this faster because we're sick of waiting. Select star is silly. I don't need to get all my columns back. So I'm just going to remove the select star and only put in the columns I care about. If I run that, my results come back instantly because now I'm not abusing my server and making it read everything out of a database that it shouldn't read. So obviously select star is going to make things slow. We're not going to do that anymore. If you don't like the Yankees very much and you want to see how bad they've been, you can similarly just adjust your results and say, hey, I want the losses. So give me the island start for losses. L, not L, instead of W and not W. So all I'm really changing here is this where clause. The where clause goes from wins to losses. Done. That's it. Same here. End and then join. So a very, very similar query to before. The only difference is I replaced the W's with L's in 4 places. That was it. If I go ahead and run this, I can find out the longest losing streak for the Yankees occurred in 1908, from July 23rd to August 6th. It was 12 games in a row that spanned 15 days. Now, of course, there's some oddball ones here. If your losing streak began in October and ended in April, it may have only been 11 games. But boy, it went 201 days. You were losers for 201 days. That's funny, right? So, cool. We can do that. What else can we do? Well, let's say I wanted to get the longest winning streak. I'm actually going to run this SQL first, and then I'll explain it while it's running. It'll be easier that way. So let's say I want to get the longest winning streak for every modern team. This is like all the teams in past 50 years or whatever. So I could write the same query like 40 times and hard code stuff into it. That's going to take a while. It's going to be messy. I don't really have time for that. I don't want to do it. But if I have a list of things I want to iterate through, I can use dynamic SQL or some other process to iterate through and give me what I want. In this case, I simply said, give me a team list. So give me all the distinct teams from the regular season for the visiting teams, the home teams, throw it into a table variable that I'm going to scan later on. I'll create a temporary table that the results go into. And there's many ways. This is just one way to do this. I'll then take my ugly query from earlier and throw it into a blob of red and splice in my team name. You can parameterize this if you want. You don't have to do it like this. We'll demonstrate that shortly. And then here we go. I run this big mess, same code as earlier, honestly. And I get the top one for each team list. So I now have each team with one row, and I have their longest winning streak. For example, the Cleveland Indians had a winning streak of 22 games once. They went from August 24th to September 14th in 2017. I can go through this list and see everything. That's the longest winning streak in baseball history, followed by the Cubs had one that went from September one year to most of the month, and so on and so forth. Some teams have shorter winning streaks. Others have longer ones. Cool. So that was a little slow to watch, though. I had to listen to my computer get louder as it did some work. We can use lead and lag again and build all the logic into one query and say, all right, I want a bigger and more complicated query. So here's what I do. I'm going to create my game log here of wins, losses, and ties. I'm going to get the home games and the away games separately into a big union here. I'm going to then order all this data because I'm going to partition it now. So I'm not just ordering the data for one team. I'm taking it and partitioning it by each team. So for every team, I'm going to partition it by the team name and order it by the game date and the ID. So I'm going to get the lag, which is the game prior to the current one for that team, and the lead, which is the one after it for the same team, and a row number. And then just like before, island start, exactly the same as before. Island end, exact same thing before. The only additional piece of information here is a team to trend, because now that's more relevant. Then I have my join at the end, and I happen to join on the island number and the team to trend. And then I get my final select. And I just get streak number 1 for each one. I don't want all of them. I just want the best one for each. So big, massive blob of scary SQL. I run it, and I got results back really fast. So this tells me for each team, I want to know the question I asked before, streaks for every team in baseball. And so I can now go through this list, and I have a lot of examples here of the longest streaks for each team in baseball all time. There's been a lot of teams, so I have a lot of lists here of information. So I did it on one query, and it finished really fast. If I filter it to be only modern teams, it'll be a shorter list, but I put everything in here for fun just to show that you can do it, and it completed in like a second, which is pretty awesome. So we don't have to have it be slow if we don't want it to be slow. A big pile of SQL, but again, if you walk through it block by block, it makes sense. It's in its entirety very large and scary, but each block is only 10 lines in SQL, and it's all just doing one thing. I'm getting together a game log for all teams. I'm ordering it, getting my lead and lag in there, getting my island starts, my island ends, and calculating my metrics, and then just getting my final results. Doing it per team and partitioning is more complicated, but why not? We can do it. So let's do it. All right. I can then say, hey, I just want to get the longest winning streak for every team versus all under opponents. Get rid of the noise. I don't want everything. Just give me the longest streak for each team versus all opponents. So for every one team versus every one other team who has the longest streak. So here's my game log again. Same deal as before. I order it, add my lead and lag in. I get my start and my end for each island. I then do my joining, and I order by the end locations to get the greatest ones there. If I run this, I get back results, and I can see the longest winning streak for one team versus another one happened in 1883. In terms of teams we'll recognize here, Baltimore had a winning streak of 23 games versus Kansas City specifically. It started in 1969 and went over a year. So these two teams played each other 23 times, and Baltimore won every single time. It went over the course of 450 days. So this is some pretty interesting analytics here that I pulled out of this data just using TSQL, and I got results back pretty fast. I learned some very interesting information that without this kind of analysis would be very hard to get. And I can look through this list and see like, wow, this streak, because these teams didn't play very often, went on from 2018 to 2021. Wow. If you don't play often, that happens. I could even order by the length of streak in days and find out who was the greatest length streak by days ever. And it might be that one, might not be. 5,169 days. These two teams, the Angels and the Phillies, started a streak in 2003 that went to 2017. Anaheim beat them all 12 times over the course of, 14 years, 15 years. That's a good one. So whenever you hear people in baseball give crazy stats, or any sportscaster giving a crazy stat, and you wonder, how could they possibly know how many games they won in a row on Wednesday evenings in the darkness or something? It's just like this in the back end in terms of the analytics. Whatever's running, it's doing something kind of like this somewhere and doing it quickly. You feed parameters in, out comes data. We can go more detailed. I can say, hey, take one baseball player, in this case, someone with a very long career, Nolan Ryan, and I want to get his wins and losses together. And I can do that. I can take all of his games and just look at them. He has pitched how many games? 781. And I can see all of them where they have wins, losses, or something else. All right. The end means a tie or no decision, whatever. There they are. All of his games. Now that I have that, I can do what I did before and say, hey, make a win-loss CTE, and then we'll get his winning streak. Start of winning streak, end of winning streak, join it all together, just like before. And again, very similar queries to before. Instead of being a team winning or losing, it's a player winning or losing. I run this query and discover his longest winning streak ever was 8 games in a row that went from August of one year to April of the next year. I can see all of his winning streaks here. And in baseball, winning 8 games in a row is a big deal. That's several months of winning. That's a big deal. And there it is. That's all of his winning streaks ever. I can similarly get additional information, like how many winning streaks has he ever had based on the length of the streak? Like how many 8s did he have? How many 7s did he have? How many 6s? I can just take these results and group by them. So I have this information down here. I can just order by it and get my results. And what did I do? Oh, I dropped into a temp table. The results from before. Now I can grab my numbers out of it, because at that point, adding more CTEs is probably just going to be complex. Now that I have it into a temp table, I can simply group by the streak and get back the information of, hey, here's all the types of streaks he had. He had 1 8-game winning streak, a 6, 4 5s, so on and so forth. So any results you get from this kind of process can be saved in a table and then crunched to your heart's content. All right, we can go further, and I can get him versus other teams and see, all right, we know how he won overall, but how did he win versus specific teams? And just like before, I'm going to add in the team names and get the opposing team for him as a single field, and then work on it. So now I'm going to say start of my winning streak is based on date and number, and I'm checking based on team in my where clause that exists. And then same for the start. I just order by it. End of my winning streak. Same deal. Big scary exists. And then I join it all together. Again, this is getting scarier, but it's the same basic idea as before. Him versus all the teams. I run this. My computer heats up, makes a little bit of noise in the background. And we'll wait for some results. We'll wait for some results. I really want results back. Waiting stinks. No one likes waiting. There we go. So we can see here all the winning streaks of his versus all other teams. It's a lot of data. I generated a total of what? Actually not a lot of rows, only 189 rows. So it looks like a lot, but it's not really that much. I can now take that and go a little further. I can get his longest winning streak versus each team if I want to. And again, like before, to accomplish that, all I do is take that data set that I just got, I throw it into a temporary table. Then once it's in a temporary table, I take that, more CTEs, right? I partition by team, order by winning streak, and then I just select out of there the first row. So I'm just getting my first row back to see versus every team, what is his longest winning streak? And I can see here that, some of his more lengthy winning streaks versus a single team, or 6-ish games maybe. He had a 6-game winning streak versus Pittsburgh that went over the course of 3 years. Because again, in any one series, you're going to pitch one time versus a team probably. So how many times do you pitch in a row? It can span a lot of time. Cool. I already dropped it. Okay. So again, you can get obscure here. This is kind of where I just say, hey, let it all out and ask a crazy question. Let's say I wanted to know something obscure. Like, for example, I want to know the streaks for night games played on Wednesdays in July by the New York Mets. This sounds silly. You can't do that. It's too complicated. Why would anybody do that? But these questions are asked all the time by people looking to understand the outliers and complexities of a data set where specific things matter a lot. If you're in sales, certain times of year matter, like Black Friday or Cyber Monday, and all the rest of your data is irrelevant when you analyze that one little piece. And so you may very well take your data set and chop out huge swaths of it to understand how did you do in very specific periods of time. And not much changes here, honestly. I take my where clause and just extend it. So I have the same as before. I'm checking for the Mets. I'm checking regular season games. And then I'm saying, all right, I want either day or night is not null, and it's night. I want only night games, only Wednesday, and only Saturday, I said? Wednesday, sorry. There we go. 7. Why did I use 7? Whatever. It's fine. So I go back here, and I get back, okay. Oh, right, because 7 in this data set is Wednesday. That's why I forgot. Crazy day. This is not the SQL Server thing. This is the month of it. I want July. July. Sorry. Anyway, so here's my data. Here's every game played at night on Wednesday in July by the Mets. There's a total of 130 of them, in fact. Now that I have this data set, I can simply say, all right, here's my CTE once again. Give me all the wins. There they are. There's a total of 68 of them. So our data set's getting small here. I filtered a lot. And now I can just combine our method of CTE of games, start a streak, end of streak, join, done. And there we go. The longest winning streak in the history for the New York Mets on Wednesday at night in July is 6. It went from 7/28/93 to 7/3/96. There you go. You want to know really obscured craziness? We can do that. One final example here. You can do more esoteric things if you want. Let's see if I understand scenarios where players perform well. I can take a player, for example, analyze every at-bat of theirs over time to understand how they did. I will take every play they could possibly get, assign a value to it for how good it is. Negative is bad, positive is good, and then find out how they did. Add index to my table. It already exists. Great. It's already there. Just checking. It's there. I'm going to take one player, in this case, Derek Jeter. I'll put his debut date in just to save a little bit of trouble. My CTE really just defines what's my number that I'm measuring, and then who is it. Then I'm going to group it, start the streak, end the streak, join it together, done. If I run this crazy query, most of the data is being ignored because we're talking about one player over a specific span of years, but it still is kind of big and chunky. My computer's crying a little bit, but I will get back results in a sec, and the results will be interesting. I'll know when was a player performing very well. And I gave very, very detailed instructions in my rules here about what things mean. You can very well change this and adjust it, make something get a bigger penalty. You could make something be worth more. Maybe a home run is simply worth more than anything else should be worth. And here we go. I can say, hey, he had this streak here from in June of 99 where he had game after game of really good at-bats. And even though my definitions up here are complicated, I distilled it down to a single row per streak. And if you were to go back in history, you'd find that these were years and times he did very, very well. You could adjust your criteria here to target more specifically certain times of year, certain types of at-bats, certain specific accomplishments. You can filter out all the ones at the bottom. As from this kind of list, you probably don't care about the 1 in a rows. You probably care about the 7s and 8s and so on. Cool. And we can keep going and going and going and do more crazy stuff. This is good enough, I think, for examples. That was a lot of examples, a lot of demo. It was very, very heavy. So I kind of want to start wrapping up and then take questions if anybody has any. If not, everyone's eyes have glazed over. That's cool too. It is a Tuesday night. I totally accept that. I've not been drinking, but maybe you are. All right. A question you may be thinking is, what about performance? How does it perform? And the answer is, this is analytics. It's not going to perform any better than the amount of data you have to scan. If you've got to scan n rows and n columns of data, you got to pay whatever the price is to scan that. Therefore, this is not meant to be run on transactional workloads. This should go on things that are meant for analytic data, whether it's replicated or always on or column store or some data copy or some other data storage device you have, whatever it is, you should run this against a place where analytic data is acceptable. If your data is very, very big and analyzing it takes a while, you can schedule things to run off hours or when you're asleep, so you don't have to wait for it. Sitting here F5ing and waiting stinks, but you don't have to wait for it. You can automate it. Every night after our data loads, run a bunch of stuff against it, give me back the results, because the result sets I had here were very small, whereas the input data was big. Once you have your small data set that your results are in, that can be plopped in a teeny, teeny, tiny table to be analyzed at will later. And again, helpful tools, lead and lag, great for performance. The new window operation, the new window predicate in SQL 2022 can shrink your TSQL a bit. It's kind of nice. And at the end of the day, the best performance you're going to get is going to be linear to the amount of data you're reading. So if you read a massive amount of data, you've got to read a lot of data. It takes I/O. It takes all that stuff that we're used to. So it'll perform as well as that. That's the best we can do, and that's fine. This is analytics. I don't expect it to be lightning fast. And if you want it to be lightning fast, we can tweak it, play with it, pre-cache our data, automate it. Some considerations. You notice that all my data sets were beautiful at the end, but when I first built this stuff, it wasn't. I had lots of bad data. So when you're considering data quality, consider things like nulls or missing data or bad data or wonky values. Think of the QA, in your heart, think of the QA person that you work with or you are, and what would they do to break your data, and consider it. If you have duplicate data, make sure that whenever you analyze a data point, one row in a gap or an island, that you don't join it to itself or join it to an event that happened the same day. They should be distinct events. Every event should be distinct from every other event. If you can't make every event separate from every other event, you're going to get cross joins and uneven numbers of events, and your islands will be lopsided and you'll get bad data. So always think about that. You're defining borders of islands that create gaps. You want those to be defined clearly. So if you run into weird stuff, test everything to see how you get your data quality perfect. End of the day, if the number of islands and the number of gaps lines up nicely, if the starts and ends line up nicely, you're in good shape. And yes, by the way, the number of gaps will always be one less than the number of islands. That's just math. You can use other tools for this. I did this all in TSQL for fun to show you that you can do this. And it can be efficient too. It's a good tool when you have it available and when you want to play with data and when you want to do it quickly and dirty and you want to do it alongside other analysis that may occur in SQL Server. If your data is already out there in some other data source and it's available for R, for Python, for other tools, feel free to use them. There's no reason not to. Use whatever tool makes the most sense for you. The purpose here is to show you that this can be done and how it is done, not that you should have to use a certain tool for it. So pick your tool based on criteria like the performance, or what do you know how to use, or how complex will the analysis be in one tool versus another. If it takes 100 lines of T-SQL here, but 1,000 lines of Python over there, maybe you shouldn't use Python. If it takes 100 lines of Python and 1,000 lines of T-SQL, Python might be kind of cool. It'd be a better way to do it. Also consider, what are you going to do with all your data next? Where's it going to go to next? You finish crunching your data. Where do the results go? Are they going to Power BI? Are they going to Tableau? Are they going to SSRS? Are they going to a person in their email? Just think about it, because you need to get the data there somehow. Cool. We've hit about an hour, so I want to wrap up and allow for questions or, drunken rambling, whatever we have. This is a cool demo on what you can do with data if you want to organically group it and make something cool out of it. I use a lot of winning and losing streaks here as a demo for how to take complex data like date times or dates or grouping by very different criteria and getting results out of it. It can be on any kind of data, any data types. As long as you can define your rules, you can group it organically and you get back results to tell you about your data and when that data is significant and when it isn't. And therefore, you can calculate lots of cool things. You can find patterns. You can find notable outliers. You can find related events and winning, losing streaks and all kinds of cool stuff. So really, the limits to this data and how you can analyze it is really in your creativity. I can tell you what I've done so far. You could probably think of 100 cool things to do that I've not thought of yet. So therefore, this is really an exercise in creativity. I'll leave it to you to use this however you want. Cool. This is the time where I stop for questions. I will post everything shortly after we're done. But if you have any questions, now is a great time to ask them. Hopefully I didn't go too fast, as I always get told I go too fast. Is that true?
I think the pace was good. So if there are any questions for our illustrious speaker, get them in chat right now. Of course, since I know that there is a little bit of a delay in terms of when we say things and when the broader world gets them, if you do have a question, it's probably quick to just type in something like, got a question, so that way I can vamp for a little bit and know that you have a question, rather than vamping like I am right now in the hopes that you have a question, and then eventually finding out that, in fact, nobody had a question, in which case we could have all just left 30 seconds earlier. So
this is called stalling for time. Good strategy.
Exactly. But I would
Definitely.
say...
Go ahead.
Oh, I was going to say, excellent presentation. It was very insightful, got a lot out of it, and as I recall, that there will be some information on how to get access to slides and information later on.
I will post all of this to the meetup as soon as we're done. I'll go on there, I'll post a Dropbox link. I'll also include a link to the baseball stats database that I used. I've posted it in the past, but it's just a useful database. It's not too big, but it has a big mountain of data that you can goof with and play with and have fun with. If you're interested in baseball at all or sports, you might find it kind of fun to have a very flattened data set that you can just goof around with. It isn't like a million tables or something you got to pay for, because a lot of the services are paid for. So this is free. I built it. It's free data. You can enjoy it.
Excellent.
It doesn't like free.
Can't beat that price.
That's right.
Looks like
that's right.
No questions for this evening, so I do want to say thank you again. We absolutely appreciate you coming on tonight and hope to see you again in the future. Speaking of seeing again, remember everybody, next Tuesday we have our main meeting. Tuesday after that, business intelligence data science meeting. All that at meetup.com/Tripass. And until we see each other again, everyone, take care.
Have a good night.